Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 18, more problems on area and circumference. So the first classwork opening exercise says to draw a circle with a diameter of 12 centimeters and a square with a side length of 12 centimeters on grid paper. Determine the area of the square and the circle. Okay, so let me do this. So I have my compass, I have my ruler, so I brought in this grid and I am going to go by twos because it's not large enough to go any smaller. By ones, I can't do that. So I'm going to start here, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess I do have room. Okay, and I want to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 is right here. A line here to there. Rotate. Okay, so there's my square, which is 12 by 12. Now I'm going to draw a circle whose diameter is 12. So let me just bring this over to here and open this up to here. That'd be radius of 12, so I want to go halfway. 1, 2, 3, 4, 5, 6. So if I move this over here, and let's try right here. So I will put a dot right here. That'll be my center. Then I'll rotate around. Okay, so there's my square, and there's my circle. Length 6, so let me mark this. This is 12 centimeters, I'm sorry. And then if I draw a line from the center to the edge, that is a radius, and that would be 6 centimeters. So this said with a diameter of 12. So if the radius is 6, the whole diameter, which I might as well just draw here, the whole diameter is 12. Okay, so let me write that. I want you to be aware that a radius is half of the diameter. Diameter twice radius. So there's a circle with 12 centimeter diameter. There's a square with side lengths 12 centimeters. It says determine the area of the square and the circle. So area of a square is side squared, or base times height, if you will. But when they're equal, then we can call them S. So this is side S, side S, side S, side S. So S times S is base times height, or length times width. But our length and width are both S, so it's area equals side squared. So therefore the area equals 12 squared, which equals 144 centimeters squared. Now if I do the same thing with a circle, the area of a circle is pi r squared. So the area of this circle is pi. Remember that radius is half the diameter, so that's going to be 6 squared. So the area of the circle is 36 pi, which is, I cannot use equals, which is approximately, and let me get my calculator. Okay, so it doesn't say to use approximation, so I'm going to do the exact. So I'm going to take 36 times pi, and it's 113.097. I'll round to the nearest hundredth, so it's 113.10. So the area of this square is about 27 square centimeters more than the circle. Okay? So let me get rid of all this because my questions are behind this. I just wanted to bring the graph paper together. Okay, so that's all cleaned up. So I don't have the answers here anymore, but it was area of the square was 144 centimeters squared, and the area of the circle was approximately, using approximate symbol, and what did I say? It should still be on my calculator, 113.1 centimeters squared. Okay, so now it says brainstorm some methods finding half the area of the square and half the area of the circle. Okay. Well, half the area of the square would be cutting either the base in half, which was 12, or the height in half, which was 12. So the area would be taking one of those halves. So what I'm saying is if I have a square and I cut it in half, this distance now, the height is now 1/2 the total distance. But this did not change. So I could say 12 times 6 instead of 12 times 12. So the area of half the square would be 72 centimeters squared. Well, look at the original, it was 144. And if I just divided that by 2, I would have gotten 72 square centimeters. So if I'm talking about my circle that was over here, and I want half of that circle, then I'm just finding the area of, say, the shaded region. And if the whole thing was 113.1 centimeters squared, an area of half the circle would be area of the semicircle, let me just do it this way, would be approximately 113.1 divided by 2, which would be 5, 6, 5, so 56.5 something. Okay, so 2 goes into 11, 5 times, carry the 1, 6 times 2 is 12, 11, 5 times 2 is 10, carry the 1.55. So 56.55 centimeters squared, that's an approximation, right? Okay, so you divide the area in half if you're going to cut the object in half. So now it says find the area of half of the square and half of the circle and explain to a partner how you arrived at this area. Okay, so I have already done that. I've explained that if you cut a square in half, that its height is going to be cut in half. Base times height is now going to be half. And so on. So now it says, what is the ratio? Ratio, that's from way back in Module 1. What's the ratio of the new area to the original area for the square and for the circle? So the ratio for the square would be 144 to 72. Okay, my area to my area. But if I reduce that, then it's 2 to 1. Okay. Ratio of the new area 2. Okay, so there I need to be careful. The word 2 means the order. So this is the 2, the ratio of the new area. So the new area's got to come first. So I did this backwards. So be really careful about that word there. New area is first, which would be 72. 2 is the colon. And then original was 144. And that would reduce to 1 to 2. Now if I do the same for the square, or the circle, then I'm going to take the area, new area, 56.55 to 113.1, which also comes out to be 1 to 2. Okay. Find the area of 1/4 of the square. Now let's, since we're starting to do quarters and all that, let's do in terms of pi here. So the area of the circle is pi r squared. So that would be 36 pi. So let's just use 36 pi, which is what this approximation is for the rest of our stuff. All right. So find the area of 1/4 of the square and 1/4 of the circle. So now if I had that square, what I'm doing is cutting it into quarters. And now I only want the area of this region up here, say. Okay. So the area of 1/4 of the square would be taking that 144, dividing it into 4 equal pieces. 4 goes into 14 3 times, 12, carry the 2, 4 goes into 24 6 times. So 36 centimeters squared is the area, the area of the quarter. So area of 1/4 of the square equals 36 centimeters. I did the same thing with the circle. What that's saying is there's my semicircle from the last problem. Then it says to cut it this way. So now I'm only talking about 1/4 of this. Picture having a pizza, cutting it into 4 equal slices. You're taking one of those slices. How much area is that? So the area of the quarter circle is 36 pi divided by 4, which equals 9 pi centimeters squared. Now it says write an algebraic expression that expresses the area of a semicircle and the area of a square circle, of a quarter circle. Okay, so semicircle, meaning half circle, will be area equals 1/2 pi r squared. Okay, quarter circle the area would equal 1/4 pi r squared. Example 1. Find the area of the following semicircle. Use pi equals approximately 22/7. So we're using an approximation here of 22/7. And it's a semicircle. So I'm going to go back. My area of my semicircle is area equals 1/2 pi r squared. Always start problems with writing the formula. Still have students not doing this on quizzes and tests. If it's asking for the area of something, then write the formula. Substitute in the givens, simplify, and solve. So we are given pi is 22/7 instead of the pi symbol. R, the diameter is 14. I need to divide that by 2, so R equals 7 centimeters. Be careful. So that is going to be 7 times 7 squared. Okay, so the area equals, this is this times this is this times this, and this is squared. PEMDAS, remember PEMDAS. Be careful, do not cancel these 7s because 7/7 divides. PEMDAS says to do exponents first if there's no parenthesis operation. So I want to square this first. So before you do anything, get rid of that squared. And that would be 49/1 now, not 7/1. A little bit better. 1/2 times 22/7 times 7 squared, which is 49. You make that over 1. And the reason I'm doing that is now this 7 and this 49 will reduce to 7. This 22 will reduce that 22 to 11. So my final area is 1 times 11, which is 11, times 7, which is 77. And these are all 1s when they cancel. So it's just 77/1, or simply 77 centimeters squared. Now it says what is the area of the quarter circle. So when I go back to my formula, a quarter circle is A equals 1/4 pi r squared. So I'll write my formula. A equals 1/4 pi r squared. Substitute. 1/4 doesn't change. Pi is the approximation, 22/7. The radius, in this case, they did give us r. Do not divide that by 2. The radius is 6. And I'm going to put that over once so we don't forget, and it's squared. Pi r squared. All right. Do my PEMDAS properly by doing the squared first. So it's 1/4 times 22/7 times 36/1. 6 squared is 36. And then reduce if possible. We always want to go smaller before we go larger, or these numbers get really big. 36 times 22 is a big, big number. It's 700 something. But if I take this 4 and know that 4 goes into 36 9 times, then that makes it easier. So now I can multiply my numerator. 1 times 22 is 22. 22 times 9 is 198. And then I divide that by 7 times 1. And does that go evenly? 7 times 2 is 14, 58. 9 times 8, 7 times 8 is 56. And so that's an approximation. So let's just leave it 198/7. I don't want a decimal approximation. It doesn't go evenly. So my answer is 198/7. My measurement is centimeters, so it's still centimeters, but since it's area, it's example 2. I'm going to do something a little differently here. It's a girl named Marjorie, and she's designing a new set of placemats for her dining room table. She sketched a drawing of a placemat on graph paper. The diagram represents the area of the placemat consisting of a rectangle and 2 semicircles at either end. Each square on the grid measures 4 inches in length. So we need to keep that in mind. This is 4 inches. So this is 4 more, and this is 4 more. So rather than writing 4 inches, let me write the total down here. Okay. So there's 3 squares with a length of 4 each. These are 12 centimeters. And this distance from here to here is 8 centimeters. Okay, so there's my rectangle right here, which is 12 by 8. So the area of a rectangle is length times width. And again, please show your formula. Then substitute in your givens. (96 square centimeters). That's just the rectangle. But it also says we have 2 semicircles. So I have this semicircle here. And I have this semicircle here. Okay, now I'm drawing these for a reason, because if I bring this down here now, and I bring this one over here, alright, there we go. Now that's a complete circle. And we know that the diameter is 8 centimeters. So the radius equals half of that, or 4 centimeters. The area of a circle is pi r squared. I could have done 1/2 pi r squared, then doubled it, but if you double a half, you get 1. So I'm just going to use the formula for an entire circle, because that's what 2 semicircles is. Okay, so area equals pi r squared. Area equals, now did they say to use any form of measurement to do this? Did they say to approximate? They did not, so I'm going to do decimals. I'll use 3.14. So pi is 3.14. The radius is half of 8, which is 4, squared. So PEMDAS says to the squaring first, which is 16. times 3.14, and that will yield 16 times 3.14. Let's use a calculator for that. 16 times 3.14 is 50.24 centimeters squared. Okay, so we now know the area of this plus this over here is 50.24, and the red rectangle inside is 96. So the total area of the entire placemat is the sum of these two. So the area will equal 96 plus 50.24, which will come out to be 146.24 centimeters squared. Oh, I'm sorry, it's inches. I was just reading through again, so I need to change my unit of measurement on all of these. So I will do that. It's very important that you're precise with your calculations. So there's a big difference between centimeters and inches, so let me just fix all these. So this should say 8 inches. 4 inches. This is inches. Inches squared. And my final answer, inches squared. And finally this one here, inches squared. So my final answer is 146.24 inches squared. Okay. Now it says if Marjorie wants to make 6 placemats, how many square inches of fabric will she need? Assume there is no waste. So there's a way to take the pieces that got cut out here and reconnect them, is what they're saying. So we're not figuring in on the lost area here. Okay, so all we need to do is multiply by 6. So the area of 6 placemats would be 146.24 times 6. And it's 797. Right? 6 times 4 is 24. 6 times 2 is 12, 14, 36, 37. 6 times 4 is 24. 27. I made a mistake there. 6 times 4 is 24, plus 3 is 27, carry a 2. 6 and 2 is 877.44 inches squared. Okay, so there's the answer for 6 placemats, assuming there is no waste on these plans. Okay, Marjorie decided that she wants to sew on a contrasting band of material around the edge of the placemats. How much band material will Marjorie need? Okay, well what you need to understand here is that is a perimeter question. Okay, so in other words, if I go back here on her placemat, she wants to do a band around her placemat like this. Okay, that's what they're talking about, just a band going around like a border. So that's the perimeter. Okay, so how much band material will Marjorie need? A perimeter is distance around, so the perimeter of a rectangle is 2L plus 2W. So I'm going to write that, perimeter of the rectangle. But keep in mind, I don't want all of the perimeter of the rectangle. I'm not going to put a band going down here. There is not going to be a band here or here. So I just want the distance, the length twice. Okay, so the perimeter of this figure is going to be 2 of the lengths plus C. So in other words, if I'm going to draw a band around here, that's a half a circle. Draw a band around here, that's a half a circle. So in other words, we've got a band going from here to here and a band going from here to here. That's the circumference of an entire circle plus the length and the length, but not counting the width of the rectangle. So be careful with these types of questions. So we're going to do the length twice plus the circumference of the circle. The length was 12. And the circumference formula is 2 pi r, and we know the radius is 4. Okay, plus 2 pi r, that's my circumference. So simplifying this, actually before I simplify it, I'm going to put in all of my information. Let's use 3.14 again, and the radius was 4. So that is going to be, the perimeter is 12 times 2 is 24, plus 8 times 3.14. I just multiplied the 4 times the 2 first. So I'm going to carry this over to here. So it's going to be 24 plus 8 times 4 is 32. 8 plus 3 is 11. 8 times 3 is 24, plus 1 is 25.12. So the perimeter is 49.112 inches. That is length. It is not area. So that is the perimeter of that band. Okay, example 3. The circumference of a circle is 24 pi centimeters. So we have a circle. C equals 24 pi c. What is the exact area of a circle? Draw diagrams to assist you in solving this problem. So circumference is distance around. Area is the region inside. So first I have to find the formulas. So if we're looking for area of a circle, area equals pi r squared. Circumference of a circle is 2 pi r. So these two things in common have an r. I need to know the radius, so I'm going to find the radius using my circumference formula. Then I'm going to take that radius and plug it into my area, because that's all I don't know about my area is the radius. So my circumference is 24 pi. So I'm going to write 24 pi equals 2 pi r. Okay, circumference is 24 pi. So to replace c with 24 pi, if 24 pi equals 2 pi r, I want to get all my pi's on one side and have r by itself. So I need to divide, because that's multiplication. So if I divide by 2 pi, 2 divided by 2 is 1, pi divided by pi is 1. And do the same over here. Pi divided by pi is 1, 24 divided by 2 is 12, and that gives me my radius. Okay, I then take my radius of 12 and plug it in to get my area. So now I'm going to have area equals pi 12 in place of r squared. So area equals 144 pi. And this is in centimeters, centimeters squared. So what information was needed to solve this problem? And the key to this was radius. The radius was needed to find the circumference. Actually, we needed to find the radius from the circumference, plug it into the area formula to find the area. So we needed the area formula for a circle, the circumference formula for a circle, and we needed to find the radius. Okay, and next find the area is what I have done. And if I drew this circle here, we found the radius to be 12 centimeters. Okay. Now it says find the area of a circle. So I'm going to stop right there. Area equals pi r squared. With a diameter of 42. So therefore the radius is 42 divided by 2. So the radius is 21 centimeters. And it says to use the approximation of 22/7 to do this. So the area equals 22/7. There's my pi. Radius is 21. I'm going to put that over 1 and square. So area equals 22/7. 1 squared is 1. 21 squared is 441. And I believe that will be divisible by 7. Let's check. 441 divided by 7 is 63. So this will cancel that, give me 63. So the area equals 22 times 63. So I'm going to multiply that by 22, and I get 1,386 centimeters squared. Okay? Next question. The circumference of a circle is 9 centimeters. So if I drew a picture, here's my circle with my center. The circumference is 9 pi. Circumference, what is the diameter? What is the radius? What is the area? So we're given the circumference is 9 pi. And circumference is pi times diameter. And we're told 9 pi. So circumference equals pi times 9, or 9 times pi. So therefore my diameter, therefore my diameter is 9. Okay, so the diameter equals 9 centimeters. What is the radius? Radius equals diameter divided by 2. Therefore, radius equals 9 halves centimeters, or 4 1/2 centimeters. Area equals pi r squared. So area equals my radius times pi. Since it's a fraction, I suppose we could use a fraction representation of pi. So I'm going to use 22/7 times 9 halves squared. Okay, so the area is going to equal 22/7. 9 squared is 81. 2 squared is 4. 4 will reduce to 2. 22 will reduce to 11. 7 will not go into 81 evenly, so we just need to multiply now. So the area equals 81 times 11. 891 divided by 7 times 2, which is 14. Always check to see if it reduces. Divide that by 14, hit enter, and this calculator is fancy. It does not reduce. It'll turn it into a fraction, and since it's the same, it's non-reducible. So my answer is area equals 891/14 centimeters squared. I also could have left this in terms of pi. So the area would be 9 halves squared times pi. So that area would be, if you did it this way, 81/4 pi centimeters squared. So either answer would be acceptable. Usually the question is more specific as to what form they're looking for. Okay, number 3. If students only know the radius of a circle, what other measures could they determine? Explain how students would use the radius to find other parts. Okay, I'm just going to bring that in because it'd be hard to write all of it. Okay, so here's an answer. If students know the radius, then they can find the diameter. The diameter is twice as long as the radius. The circumference can be found by doubling the radius and multiplying the result by pi. The area can be found by multiplying the radius times itself, or squaring, and then multiplying that product by pi. So just knowing the radius, we can find diameter, circumference, and area. Number 4, find the area in the rectangle between the two quarter circles. Okay, so they're looking for the area in the rectangle between the two quarter circles. Okay, so what we're basically doing is getting rid of this piece, getting rid of that piece. So if we cut that out, we're looking for the area of this shape right here. Okay, so area of a rectangle is length times width. And the area of a circle is pi r squared. This is a quarter circle. This is a quarter circle. So this is a total of a half a circle that we're looking for the area of. So that's the first thing we do. What formulas are we going to use to answer this question? Write the formulas down so we can substitute the given information in and find our answer. Find the area in the rectangle between the two quarter circles if AF is 7. So AF is 7. Well, AF is my radius of my circle, so now I know R equals 7. FB is 9. FB is right here, that's 9. So this 7 plus 9 would make the total side of 16. 7 plus 9. 16, 16. Opposite sides of a rectangle are congruent. HD is right here. Well, I already know AH is 7 because that's also a radius of a circle. And HD is 7. HD is 7. So 7 plus 7 is 14. So that tells me that. Use pi equals 22/7. Each quarter circle in the top left or right corner have the same radius. So we know that that's 7, we know that that's 7, we know that that's 7, we know that this is 9. So we know everything. We can even find this diagonal, but that's a different lesson. Okay, so area equals length times width. So let's start off by finding the area of the whole rectangle. So the area equals 16 times 14. So area equals 16 times 14, 224. Now I go back up here and we're talking about feet, so that's feet squared. So this whole diagram is 224 square feet. We need to subtract 2 quarter circles or 1 half circle. Okay, hopefully you're following along with that. So the area of, that's a half circle by the way, not a whole circle. The area of the circle is going to be 1/2 times pi times 7 squared, because that's my radius. So the area equals 1/2 pi times 49. So the area equals 49 over 2. Right, 49 times a half is 49 halves, and they said to use 22/7 for pi. Okay, remember what I said before? These get really big. If I take 49 times 22, it's a huge number. Then I have to divide it by 14. In other words, it's easier to make things smaller before you make them bigger. 49 divided by 7 is 7. 22 divided by 2 is 11. So now I have 1s in the bottom, and I'm just multiplying 7 times 11. And we all should be able to do that in our head. So the area is 77 feet squared. That is this piece here plus that piece there. So I want to subtract those. So now I'm going to take the area of the rectangle, 224 feet minus 77 feet, my circles, my 2 quarter circles, subtract. So the area of this shaded region here, or not shaded, but this region excluding the quarter circles, is 147 feet squared. Right? I can't stress enough that when you're doing these problems, you need to show all of your work. You need to write formulas, substitute and solve, nice and neat. The A lines up, the equal sign lines up, the substituted pieces line up, and we get a nice, neat answer. Okay? Same with this. All the A's lined up, all the equals lined up, and we come up with a nice, neat solution to our answer. And then combining these or subtracting, we get a good answer, and it's accurate, and it's neat, and I can see all the work that was done. That's the end of lesson 18. Go do your problem set.